All right. Our final method for solving quadratics is called the quadratic formula. And let's dive into it. So this is the formula right here. This one right here. That is the formula. And we're not going to take the time to do this in this video, but where this formula came from was actually by taking this, just the standard form of a quadratic quadratic equation, and completing the square on it, right? So if you were to take this, and you can do this yourself if you want to, you can take this and you can do completing the square on it, and you'll end up with this formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that you're going to have to memorize. This is a formula that you need to know in your head. Right? So there's all kinds of different ways you can memorize it. You can just straight up memorize it. You use flashcards or whatever else, or practice it bunches of times, write it down over and over again, all of those things. You can also learn it. You can find videos on YouTube of people singing it to Pop Goes the Weasel, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Right? You can do that. That's kind of the classic. And then there's also a video that's floating around. I don't know who makes it. You can put it in the comments if you want to, if you happen to know where it is. But there's some folks that do the quadratic formula to Crank That by Soldier Boy. That one is also a great way to memorize. But in some way, shape, or form, you're going to need to memorize this chunky beast of a formula. That's enough talking about it. This is the formula. Let's do some examples using the quadratic formula. Here we go. So we're going to solve this by using the quadratic formula. Now, I don't know if you noticed or not, but in the quadratic formula, we start with the standard form. So remember I said in the last in the last lesson that the only method that we're going to learn where you don't want everything on one side equal to 0 is completing the square, right? And so our first step on this is going to be to move this negative 20 over. So we're going to take and we're going to add 20 to both sides to get everything on one side equal to 0. So we're going to start out with x. Didn't mean to do that. X squared minus 12x plus 20 equals 0, right? So we need A, B, and C here, right? So A is the number in front of the x squared term. That's A. And B is the number in front of the x term right there. And C is the by itself, right? We've seen all this before, right? So we're going to just take and plug all of this into that quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't know, something close enough. All right, so that's a 4. All right, you have it in your notes because you just wrote it down, right? So I'm going to just write all of this down with parentheses wherever the letters are, just like we always do. Right? And this is kind of important for this one in particular, because that one, sometimes we've got to ka-chink that and it'll turn it positive. Sometimes, which is why I say, I actually learned this from a college professor one time, that instead of saying negative b, I say the opposite of b. So in this case, b is negative 12. The opposite of negative 12 is positive 12, right? So you can think about it that way if that helps you remember the opposite b in the front, right? So over 2a. So we're going to plug in b right there. So b is negative 12. We're going to put a b right here, negative 12. For a, there's nothing there. What's there? Remember, hidden 1. I'm going to put a 1 right there. C is 20. And this is a, right? So now we're going to just kind of walk this down and simplify our answer down to a final solution. Ka-chink that guy, right? Bam, bam. Turn it into positive 12. Again, the opposite of negative 12 is positive 12. Plus or minus The square root of b squared. Negative 12 squared is positive 144, because a negative times a negative is positive. And then minus 4 times 1 times 20 is 80. All over 2 times 1, which is 2. Right? So 12 plus or minus 144 minus 80 is 64 over 2. So now what do we end up with? Square root of 64 is 8. So 12 plus or minus 8. I think you may have figured out that we could have actually factored and found the solution. So we're going to get whole number answers, or at least rational ones, right? 12 plus 8 is 20. 12 minus 8 is 6. No. I messed up a whole bunch of stuff on the last video, so I'm second guessing myself on everything I do. 12 minus 8 is 4. So we've got 20 over 2 and 4 over 2. So this equals 10 and 2. If I make mistakes in this particular video, you're welcome to point it out in the comments. I've been all over the place this afternoon. Hopefully I'll catch any mistakes I make before I put the video out. But there it is. That's how we're rolling today. So we got whole number answers, which means this could have factored to begin with. But that's all right. That's all right. We're getting good, easy practice with quadratic formula. Right. So we're going to solve that using quadratic formula round to the nearest tenth if necessary. That's signaling that something's going to happen. Now, unlike the completing the square, a can be whatever it wants in the quadratic formula. So a equals 3, that number in front of the x squared term. B equals 5, the number in front of the x term. And c equals negative 12, the number by itself. So we're going to plug this into the formula. You should have the formula in your notes already at least once, maybe even twice. So I'm just going to start by putting it into parentheses on this example. I don't know that we drew that quite far enough. So this squared minus 4 times a times c all over 2a. We're going to take and plug in 5 for b, and 3 for A, and negative 12 for C. So this equals negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times times positive 3 times negative 12 is positive 144. 2 times 3 is 6. So this equals negative 5 plus or minus the square root of 25 plus 144 is 169. I don't know if that's going to come out pretty. I bet it's not going to. What do y'all think? Let's do it in the calculator and see what happens. Grab our calculator over here, and square root of 169 is 13. Oh, I knew that in my head somewhere in there. So, negative 5 plus or minus 13 over 6. Split this into 2. Negative 5 plus 13 is 8. So 8 sixths. And negative 5 minus 13 is negative 18 sixths. Doesn't sound right. Is that right? Negative 5 plus 13 and 3 is 8. And yeah, I think it's right. 8 sixths reduces to 4 thirds. Negative 18 over 6 reduces to negative 3. So that is the correct answer. You could also do 1 and a third negative 3. that would also be true because 4/3 is 1 1/3. Easy peasy. You wouldn't want, because we can write this exact, you wouldn't want to do approximately equal to 1.3 because you're unnecessarily rounding, and we don't like that. We like to keep things as exact as we can within reason. All right, let's do another one. So this one, we're going to subtract 25 from both sides. 25. So we end up with 10 x squared minus 5x minus 25 equals 0. Now, on this problem, let's take a look at this problem. So we can make our lives a little bit easier on this problem because 5 goes into all of these things. So let's kind of reduce this. Now, if you didn't see this, you would still get the right answer. If you did A is 10, B is -5, and C is -25, you would get the same answer as doing what we're about to do. But this way, if you happen to see that you can reduce it, that can be a great way to get make your life a little bit easier, make the numbers easier to mess with, right? So 10 divided by 5 is 2, so 2x squared minus x. You could write -1x if you wanted. 5 equals 0 divided by 5 is 0. And it's legal to do this because we did that. We divided 0 on both sides, right? So this might factor, don't know, but we're going to solve it using quadratic formula. So this time A is 2, B is -1, and C is -5. So let's plug it into the formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Just going to have to memorize it. I don't know. I don't know how that one goes. I've never heard that video. Crank that quadratic formula. I don't know. I don't know how that one goes at all. You'll have to look it up and let me know in the comments how amazing it is or whatever. Right? So we're going to put a -1 in for B and a 2 in for A and a -5 in for C. So -1, that we got a ka-chink. The opposite of -1 is 1. You can think about it either way, plus or minus the square root. -1 squared is +1. -4 times 2 times -5 is +80. Oops. Thinking ahead. 2 times 2 is 4. One plus or minus the square root of 81 over 4. Square root of 81 comes out as a whole number, right? Why are these all pretty? So 1 plus or minus 9 over 4. Okay, 1 plus 9 is 10 over 4. 1 minus 9 is -8 over 4. Both of those reduce. So 5/2 or 2.5, either one. You could write either one. It'd be totally fine. And -2. Great. Let's do another one. We're going to solve this one by using quadratic formula. Round to the nearest tenth if necessary. So we're going to subtract 12 from both sides. -12 minus 12. Canceling over there. Gives us x squared minus 4x minus 12 equals 0. So A is 1. Nothing there. It's a 1. B is -4. And C is -12. Let's plug it into our quadratic formula. All the ones so far that we've seen, we could have also factored them. We know that because of the types of answers we got. If the answers aren't irrational, then you could have factored it. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to take and plug in negative 4 for b, 1 for a, and negative 12 for c. So negative 4, ka-chink that, and end up with plus 4, plus or minus the square root of negative 4 squared is positive 16. Negative times negative is positive. Negative 4 times 1 times 12 is plus 48. 2 times 1 is 2. 16 plus 48 is 50 plus 8 plus 64. I don't know. My brain feels like I don't trust myself at the moment. 16 plus 48, 64. Got another one that has a whole number answer. Okay, so 4 plus or minus the square root of 64 all over 2 equals 4 plus or minus 8, because square root of 64 is 8 over 2. 4 plus 8 is 12 over 2. And 4 minus 8 is negative 4 over 2. So this equals 6 and negative 2. Great. All right, so we're going to talk about a concept real quick. We're going to do one example using it, and then we're going to be through. So the discriminant. What is the discriminant? Well, the discriminant is the under the square root part, just the b squared minus 4ac. And we can use the discriminant to find what kinds of solutions we can get out of the quadratic formula. So if the discriminant is negative, if it's less than 0, then it has no real solutions. And so if we were to graph and solve it by graphing, it would look something like this. It could also be something like that, right? But it's not going to cross the x-axis if this is true. Now, if the discriminant is 0, then you're going to end up with one real solution. It's going to look like something like this, or even something like this, where it just kisses that x-axis and there's only one solution. If it's greater than 0, like the ones we've been doing, the examples we've been doing, it's going to actually cross through the x-axis in 2 places, and we have 2 real solutions. Let's do that last example. Here we go. We're going to state the value of the discriminants of this, then determine the number of real solutions of the equation. So we need this to be in standard form. So just like we've been doing, we're going to add 3 to both sides. So we end up with 4x squared plus 5x plus 3 equals 0. So a is 4, that number in front of the x squared term. B is 5, that number in front of the x term, and C is that number all by itself, which happens to be 3. Now, so to use the discriminant, the value of the discriminant, all we are going to use is we're going to use B squared minus 4AC, and that's it. That's all we're going to do, because that's all we care about on this particular problem. We don't care what x is. All we want to know is what is the discriminant and what types of real, or the number of the real solutions that you can have. So B is 5 and A is 4 and C is 3. So 5 squared is 25, not that color. Oops. 25 minus 4 times 3 is 12 times 4 is 16. So try again. Is 48. 12 times 4 is 48. 48. So 25 minus 48 is negative 23. Now, so if we go back and look at our notes, if the discriminant is negative, then it has no real solutions. Oops, that's not what I wanted to do. Nope. No real solutions. So this is the value of the discriminant and no real solutions. That is it for this lesson and this unit. We'll see you later. Have a good one. Adios. Hasta luego.